Okay, good afternoon, everybody. So, if we are here today, it's because we acknowledge the potential of quantum computers. But still, we also acknowledge that quantum computers today are not able to tackle real-world problems. They does not offer an alternative for classical computers and classical computation. Why? Oh, this is back. Beg your pardon. No. Where's the key? Ah, the green one. It's very small. No. Ah, the big one. Okay, beg your pardon. So why they does not offer a real advantage over classical computers? Well, definitely hardware is a limiting factor that prevent us to reach a quantum advantage. But this is just part of the story. Software plays a huge role too. There are some problems that can be addressed by software only that limits the performance of quantum computer. I'm talking about problems such as compilation, quantum control, the control of physical qubits, embedding, routing, error mitigation techniques, and so on. So if we want to squeeze out as much computational power as possible from those devices, we need today a middleware, but also in the future a middleware that is able to I would say, exploit quantum resources efficiently. And this is our mission at Q-Brain. What we are going to do is build a middleware, an optimized middleware that exploits state-of-the-art artificial intelligence techniques that is able to control the hardware efficiently and make quantum computer useful. So our software, Cortex, is an hardware agnostic artificial intelligence engine. We try to be as hardware agnostic as possible because today it's pretty much hard to forecast which kind of architectures will be dominant in the future. And this is one of the reasons why we are using artificial intelligence. But basically, Cortex is a modular program that it's addressing several problems that are designed, for instance, for gate-based quantum computers. So we exploited the reinforcement learning technique, for instance, to compile circuit on the hardware to control the physical qubits. But we also have neural networks model that are capable of performing error mitigation. And we also have solution for analog computers too. Here, again, we have quantum compiling problems. That means embedding the algorithm on the hardware, but also mapping the algorithm across the whole QPU in order to exploit all the QPUs efficiently. And also, we have machine learning techniques that are capable of finding which are the best hardware control parameters that run the algorithm on the hardware. So what are the benefits of an optimized middleware? Well, basically, let me give you just an example with the graph on the right. So here we exploited quantum computers to solve an NP-hard problem. And well, details are not important, but I just want to point out that the yellow dots represent the execution time on the hardware in order to find the optimal solution as function of the dimension of the problem. And these results were gathered by using a non-optimized middleware. While with the green dots, we have the same problem on the same hardware, but exploiting our solution, so an optimized middleware. And as you can see, we were able to reduce the runtime by a couple of orders of magnitudes, but we were also able to embed a larger problem on the hardware. And this is just by exploiting software. So that's our mission, that's our goal, that's what we want to build. So who's gonna buy an optimized middleware, right? Well, potentially everybody is interested in an optimized middleware, but we started looking for the end users as potential customers. So we have a couple of collaboration with the Italian company NI and Banco BPM, which is a bank. But next year, we'll also want to understand if application vendors could be customers too. And we have some initial conversation with Multiverse, which is, by the way, very interested in this kind of technology. And started from 2025, we will also look for hardware partners in order to understand if we can be embedded directly on the hardware. So, of course, if we want to build an optimized hardware, middleware, it's a long journey, and collaboration networks are primal. So, as I mentioned, we have a couple of collaboration with the industry, and basically, this is extremely useful for us in order to benchmark the performance of Cortex in real-world use cases, but also for steer the development of the software. Of course, we also have collaboration with academia, because it's extremely important to be updated with the technology, with the hardware, but also with the artificial intelligence technologies. And also, it's also important to be part of a network. So, of course, we are a member of QBN network, but also we recently graduated at the Creative Destruction Lab, which is an accelerating program at Toronto that gives access to a broader network, I would say North American network. So this is the founding team. On the right, we have, I would say, the tech guy. We have different expertise. Marco, our CTO, for instance, is an expert of gate models, quantum computers, and variational algorithms, while Lorenzo is more focused on analog computers and the wave machines. And myself, well, I'm in charge of artificial intelligence solutions and also problems such as compilation. And on the left, we have our lead scientific advisor, Professor Enrico Prati, our CEO, and Paolo Arletti, which is an entrepreneur in the city market. So as a team, we are strongly connected with academia. We have lots of publication related to quantum computing, but also artificial intelligence. We also have a couple of patents, but also in quantum computing applied to artificial intelligence and artificial intelligence applied to quantum. And this is something that we want to carry on because it's important to be part of the research and to be at the edge of innovation. So if you are interested to know more, I will stay here also tomorrow, so you can just stop me, or you can drop us an email if you just want to know more. So thank you.
So from what I see, you are working with end users now, and you envisage to work with quantum providers in the future, and actually a software provider like Multiverse. What would be your ultimate business model? Would it be working with quantum hardware at their level? Would it be to work with end users? How do you see sales being done?
To be honest with you, well, it is a very great question. Definitely not the end user. It will be great to be part of the hardware, to be embedded on the hardware, but it's very hard to get there. And so that's the reason why we developed, a journey to get there. Yeah.
And maybe to elaborate on that one, how do you intend to protect your position when you see those hardware manufacturers that want to go up in the bottom stack of the software and may not be willing to partner with one of their competitors?
Well, definitely. So if I understood correctly, building quantum computers, it's a huge challenge. So definitely hardware providers, they are not interested in optimizing their software because they have different challenges. We have different competitors, but it's true that working with artificial intelligence is not easy. I'll be honest with you. It's a great tool. It's very powerful, but you need knowledge and you need time to develop the product. So probably this is the way we will protect ourselves from competition. Patents are an option, but I don't know. I mean, I've heard a lot of different opinion about that. Probably there's not will be our cases because we're working on software. It's harder to make a patent on software, and also this is a very evolving ecosystem. So you can make a patent, but after 6 months the architecture changes. So I don't know. I don't think that IP will be our way to protect ourselves. Knowledge probably will be more interesting.